Just little background here. We have these ExO Washington, D.C. meetups every month. So the next ones coming up are outlined. Then we also have some ExO clinics. We definitely want to make sure that if you have any questions at any point with some of the attributes, as we call them, how to apply to your business, or you're not clear on something, we have these open clinics for you all to attend as well. And then we'll kind of brainstorm there with you in that sense. But again, my name is Steven Rodriguez. I work over at Techstars, and I'm an ambassador for ExO. And I love just the mindset and this revolution of exponential technologies, these organizations, so to speak. And so leading it here in Washington, D.C. with some other cool cats. And today's awesome guest speaker, because we love to deep dive into different attributes every month, is Kent Langley, co-founder and chief science officer at OpenExO. He's going to be deep diving into algorithms. So welcome, Kent.
Hi, everyone. I'm here now, and I've got my Atari shirt on. So one of the earlier also was not the plan this morning, but but here we are. So why don't I introduce myself briefly, Stephen, or did you do that already?
Yep, I introduced you briefly, co-founder and chief science officer at OpenExO Incorporated.
Yeah, so I wear many hats at OpenExO. The sort of original or OG hat is co-founder. We originally co-founded OpenExO Incorporated, which is a public benefit corporation, quite a few years ago now. And there were 5 of us, 5 original co-founders. Today, the original co-founders are myself and Salim Ismail. We have a team of about 15 that is spread all over the world that does all the work of supporting the OpenExO community, the OpenExO ecosystem, running things like EXO World Media, the platform for OpenExO, which is where all of our community members, something like 7,700 of them now, connect and transact in the marketplace, as well as we've created a baseline economy called the EXO economy that has its own digital currency called EXOs and its own public permissionless blockchain. So just to give you a sense a little bit, the primary roles I hold are co-founder, chief operating officer, and chief science officer. The operating officer means I'm handling most of the day-to-day operations of the company. The science officer means that all technology is reporting into me. So people would call that the chief information or chief technology officer, I guess, but I roll it up into CSO because we're a distributed organization. So there are many divisions that have their own sort of heads of technology. And that's kind of what's going on there. So it's a lot of things. And what I'm here today to talk about, though, isn't so much that, but Stephen contacted me and he knows my background in data science, data operations, and some of the things I've been doing. And so what we're going to do for the duration of this, Stephen, just real quick on checking with logistics, how long do you want? And I mean, me talking at people versus me just having good conversation with people.
Sure, well, we have a good 30 minutes, I would say 30 to 40. And
Okay,
then the wrap up is, and as much as Q&A that can be wrapped up in there within those 30 to 40 minutes. And then afterwards, it's just a plug for the next event, and then we wrap up.
Perfect.
At the hour.
Okay, great. So what we'll do today is I'm going to do kind of an abbreviated form of a kickoff to a workshop that I do sometimes for companies that want to transform their organizations into data-driven organizations, being able to sort of leverage the transformative power of data at scale. We're going to do that from within the context of the ExO model and where it lives. So I'm going to show first to make sure that everybody is familiar. Let me pull up this image of the ExO model. The ExO model is 10 attributes, and this is the series of events that Stephen is doing. And I'm here just to talk about really what can go on in one of them today, and somewhat in the context of ExO. So I just need to pull up this one picture, and I'll show it first. It'll be a great place for us to start. Let me find a nice one. Borrowing from Google Images here. So this is, I think, going to work out for you. Okay, we'll use this one. I have no idea whose picture this is. It's just, I found it on the internet just now. And I will move myself out of the way so you can all see this here. All right, so Stephen, it'll be easiest if you spotlight me to make me go full screen for everybody.
Done.
Okay, thank you. So what you see here is the model that we're talking about. There's a series of internal attributes and a series of external attributes, and on top there, an MTP, or a massive transformative purpose. Today, we're only going to focus on the A in scale, so SCALE on the right, algorithms. So if we zoom in a little bit here, we should be able to say this is where we're going to be focusing today, is on algorithms, because this is when you think about the EXO model as a whole and you want to turn a company into an exponential organization. Once you get your process down, once you understand how to make the creation and deployment and operationalization of algorithms just a normal part of the business, it's one of the most, in my opinion, it's one of the most powerful by far attributes that you can put into play. And this is why you hear things like Mark Andreessen saying, data is eating the world, right? Or software is eating the world. What I say, sorry, is that it's data that's eating the world. And we need to actually figure out how to deal with it. And it is algorithms that have the possibility of consuming the data itself and then producing insights. So when I think about data science and the mastery of data science for an organization, that's what I'm talking about when I really dig deep into algorithms. Because if you're going to do data science, if you're going to create artificial intelligence, or if you're going to leverage machine learning, this is where you're going to do it. And the key thing to know is that you're going to want to do that in the context of other attributes. It doesn't just sort of happen on an island in a division in a corner or a dusty room in the warehouse. Algorithms are best implemented by leveraging other scale attributes like staff on demand, community and crowd, even leveraged assets and engagement. And the more autonomous you can make your divisions with a tool like algorithms, and the more experimentally driven your organization is, the better you do of a job of your dashboards so that everybody can get near real-time feedback on the output of those algorithms and models. And the more interfaces, we're going to talk about this as sort of the penultimate outcome of implementation of algorithms in an organization in a moment. So I'll leave that one for now. And if you think about social technologies, one of the ways you can gather information is that you can have algorithms that watch what's going on in your social media, in how you use social technology within your own organization. Things like Slack produce enormous amounts of data that otherwise becomes just data exhaust. So it is not until you master your capabilities with algorithms, in my opinion, from an exponential organization's perspective, they're really truly capable of implementing the EXO model in a very, very significant way that also becomes what I think of as ambient, meaning the machine is just working, and it's working for you, not against you. So that's why I like to start with the model itself, especially in the context of a little workshop like this, where we're talking about a single attribute of the EXO model. You still need to know where that lives really within there. So the next thing I want to do is I want to jump over and do a couple of slides. And the goal of these slides primarily is because I want to show you where, whenever I start talking about this, and again, I'm giving you kind of a slice of what I would do if I was going into any large or small organization. So let's see, I'm going to hit the, let's make sure this works. And obviously every time it's backwards, why not? We've got algorithms and data, so there's sort of this presentation, if you like, that I like to do here. And I'm going to go through, a few slides so we can do this. And double checking the chat real quick. Everything looks okay there. But folks, while I'm talking, because I'll probably just go through this quick so we have more time to chat, you can put some questions or comments or thoughts inside the chat, and I'll keep an eye on that over there. If I see something particularly interesting, I'll stop. Otherwise, I'll hold them for Q&A in just a few minutes. Sound good, Stephen?
Yep, sounds great. Thank you.
Okay, great. All right, so here we go. So So what we want to think about first is um, we want to think about how do we interface with algorithms? How do we actually see what's going on? How can we, as people who don't necessarily think in binary like computers, get a really good feel for the types of outputs? And there's some amazing technology coming online these days. What I want to show you next is I'm going to try to do a live demo of some samples from a tool. It's from some friends of mine called Flow. And Flow, you can find, I'll tell you the best place to look at Flows is if you have TikTok. They produce all of these incredible videos and they put them out on TikTok. And so I'm going to see if I can show you one of these right now of an example. Okay, here's one. Let's try this one. See if I can make this full screen. This is my friend, Michael. And I know that's tiny. I'm trying to find a way to make this bigger for you. Hang on. Okay. I don't think I've ever done a TikTok over this kind of screen share. Okay, so this is Michael. He's in his own living room and he's interacting with epidemiological data in an augmented reality fashion. As you can see down there, Michael does have a small child. And so imagine, right, that it's your job to analyze, say, the COVID-19 related biology. And now, instead of just looking at a flat 2D representation or even horrible, a printout, you can actually put the data in your living room, you can walk around it, you can explore it, and you can see what's going on. And that's exactly what we're seeing Michael do here. And this is just one tool. There are many, many tools like this coming online now. And I just happen to think the Flow team is doing a tremendous job of getting this done. So that's one thing I wanted to show you. Now, if I can go over here, let me see if I can show you. Here's a really fun one from the United Nations, which is what the slide was on climate change. So let me see if I can get logged into this one. Okay, so this is a flow. We're going to go full screen, so it'll look a little nicer. And I'm going to click play. Let me put my do not disturb on. Just got a bunch of text messages. Okay, so this is climate action in action. So what you're going to see here is the team that created this flow has built up a bunch of information and data. And instead of just looking at a 2D spreadsheet, what you're looking at here is a really beautiful 3D representation of all of this data. And I'm not giving you a presentation on climate change, okay? But the idea here is that what you're seeing is a way that if you were giving a presentation on climate change to your customer or your boss or your significant others, if you needed to convince them, this is a much more powerful way to do so. Now, every single thing that you're seeing, I started you with a little TikTok video of an augmented reality. This is more of a VR version. Any of this data, and in this format, you could be looking at this also in your living room as well if you have the right gear set up. So this is just another example of the way we can use data to tell stories. And that's really what I wanted to get across, is that if you want to be effective in the use of algorithms, then you need to start finding stronger ways to tell stories with your data. And the Flow team is just, again, one example of many. A lot of people use Tableau. Tableau has taken on a huge portion of what we see, again, with the COVID-19 pandemic, data reporting by civic leaders. It's just worked out really well in that case. Now, it's not as cool as the 3D augmented reality walkthroughs. But now, if you want to even get to the point where you can share this kind of data, you've got to start to learn how to actually, well, first you need to know what's even possible. And there's been some interesting developments in hardware over the last 6 months. And Landon Daddy's on the phone, okay? What's wrong? Okay, excuse me, everybody, I'm so sorry. Okay, I'll tell him later. Oh my gosh. So we're still in homeschool here, and that was my 4-year-old who's apparently having an argument with his 11-year-old brother. All right, back to the RTX 3090. So if you are thinking about wanting to do some data science in your business or in your house or whatever you want to do, the thing I want to encourage you is that there's a bit of hardware that's come out over the last little bit, like the M1 Max, like the RTX 3090, although they're currently hard to get because people keep buying them to do Bitcoin mining and other types of cryptocurrencies. We have the capability now to do data science at a level in our homes with hardware that just costs a few $1,000s. That is insane. I mean, it's unbelievable the amount of power you can have available to you for under $5,000. So a lot of people for many years have told me that it's just it's too expensive, right? I need to be like Google and have 30,000 machines available to build a model. No, you don't. The technology has changed so fast that this is within the reach of anyone who really wants to get it done. We've got incredible libraries like JAX, like FastAI, like TensorFlow, and many flavors of TensorFlow. And by the way, something that we're doing here, everyone, I don't expect you to get all of these things in one 20-minute shot of information. But what you're learning here are the words that you can go out and search and learn. So go out and see what JAX is. Especially go to fast.ai. If you have any desire at all for you or your corporation or company to implement machine learning or build artificial intelligent algorithms and models, you need to go check out fast.ai. That's the actual URL, fast.ai. It's amazing, and they just put a book out as well. It's a lot more accessible, I think, than things like TensorFlow. So you should check that out. We've got very incredible breakthroughs happening on a day-by-day basis. This was a project called AlphaFold that used some of the hardware and techniques and things that I was just talking about to solve a 50-year-old, what they call 50-year-old grand challenge in biology, decades before anybody thought that this was going to happen. And the reason they're able to do that is they're able to do predictive models of protein folding, which allows you to be able to predict how, say, a medicine will impact somebody, for example. So, and what you see in these two rotating images here on the top left is that the experimental results versus the computational prediction. So the blue was what a computer said would happen. And then when they actually did the experiment, the green is what really happened. You can see how absolutely close they are. So being able to do this level of accuracy is what the big breakthrough was in protein folding. Now, they didn't do this on a single RTX 3090 on their iMac, right? But the reality is they used Amazon Web Services and other types of computational capabilities like that, cloud computing, in order to build these models. And it wasn't and by the way, it wasn't just having access to more compute or better networking that made the change. It was actually modifications to the algorithm that made them dramatically cheaper and more efficient to run on that hardware that led to breakthroughs in a 50-year-old problem in protein folding and results that are so accurate as to, you might as well have just run the experiment. What that leads to is the concepts around simulation environments are becoming increasingly real. So another thing, this is I'm going to shift now. I'm going to say, okay, well, I've shown you a few things that in science. Okay, I do have some questions coming in. One moment, please. Oh, okay, great questions. I'll get to those in just a minute, John. Thank you. So what I want to talk about next is I want to give you some tools about how you can think about an approach to mastering data science, mastering the implementation of algorithms for you or your clients. So first and foremost, I think of data as a strategic asset. What do I mean? And why did I put a picture of a building there? Well, because most people don't think of data this way, but if you invest in data in the same way that you would invest in improving a piece of real estate, you do the math differently. You wouldn't count as much. There's a cost to acquire, there's a cost to build it, but then there's an ongoing maintenance cost as well, which oftentimes, say in a real estate scenario, can be much larger than the initial investment, even if the initial investment is large. But the reason you should think of data as a strategic asset is because you need that data to build meaningful algorithms that can make really good predictions that you can then use to make good business decisions that can put you ahead of the competition. So if you think of data and invest in data as a strategic asset, you will get a far superior result over time. But just like in things like real estate, it doesn't happen overnight. It requires ongoing support and maintenance and upkeep, and not just sort of throwing a little bit of money at a project and producing a PowerPoint report. That's not the outcome we seek if we want to have an effective implementation of data science or algorithms at scale. Okay, so I made an assertion about a definition of data science. A data science is sort of just a process that helps you make a prediction, that helps you make a decision. So it helps you achieve insights from the data you have. Over the years, and I've been doing this a really long time, and again, I came into this morning's call from a little bit of chaos, so I apologize for that. But there is, and it's actually a really nice example, when you kind of have a process and you have a checklist of sorts, you can go through that chaos, the same chaos I might be dealing with today, and you can find yourself a really sane, logical path to data literacy and mastery. And it is that path, that logical path we can follow, that will help you find, develop, implement algorithms, turn them into predictive models. A lot of people call those predictive models artificial intelligence these days, that will allow you to make those business decisions. So what does that path look like? Well, there are 6 steps. I've derived these 6 steps from my work in business intelligence, data science, over years, and put them together in a way that I think is pretty consumable for any business, frankly. And there are 6 primary steps you want to go through. When you're going through these 6 steps for the first time, it's like when you're learning to walk. You'll stumble around a bit, you'll fall down, you'll run into things. It's okay, because you're just sort of learning. You're building up your muscles, your coordination, you're getting stronger. But the very first thing any business has to do, if you really want to dig into the algorithms attribute of the ExO model, is to ask a few things. You've got to identify what you're trying to do, right? What is it you're trying to solve? What's the outcome you seek? What's the question you're trying to answer? What problem are you trying to solve? What decisions do you need to make? And what are your needs? If you don't have a cogent answer for that, that you think you can apply data science to and derive algorithms from your efforts and produce predictive models, then you don't have any business moving on. So this is a strict waterfall methodology, and I'm kind of a distributed decentralization kind of guy, but in certain cases you need this, and I'll show you how you can get to a more decentralized, distributed way of doing this in a moment. But first and foremost, what's your business need? That's what I'm saying. So identify the business need, and maybe think of these 5 bullet points as a way to get the questions going that'll get you there. Second thing you need to do is you need to acquire the data you need. How will you do that? Well, what is it? You're either going to build it, you're going to buy it, or you already have it, and you need to get it into shape so that it can be used later on in this process for creating the algorithms you seek. So you're going to maybe there's a gap in the data in your organization and you can't answer questions. Let's say you're working in a customer support scenario and you need to find out more about the demographics or psychographics, but you don't have access to that data. So you might go out and partner with a company that collects that kind of data. So now it becomes part of your database as well. You don't have to rent that, buy that sort of thing. If you have the possibility and you want to do this, you want to own the data because you think it will provide you a competitive advantage, then you should build it. Many times what I find when I go in and I talk to companies that want to put algorithms into practice is they already have a ton of data and they're doing absolutely nothing with it and paying a fortune to maintain it. This happens all the time, especially when I hear words like data warehouse or data lake, especially as a kind of a waving flag saying, okay, they've spent a lot of money to acquire a lot of data and save a lot of data and have a lot of data, but are they doing anything with it? And in many cases, you'll find that you simply can't get the data you want from the operations you have. But there's a synergistic reason you might want more. So you might have to go out and buy some data. Once you've done that, once you've found the data that you think will help you identify, will help you resolve, or let's pick an example, answer a question. Well, now what you have to do is probably 70–80% of the work of data science is right here in this third stage. You've got to clear it, clean it up, normalize it, so as it's coming into the system, it's coming out the other side of your processes, your preparation processes in a similar fashion, by standardized formatting. And then you have to operationalize the input of data from one side and the output of data into your actual data science processes, which come next. So you might think, my gosh, half of the process is just about thinking about what you want to do, getting and finding and getting access to the data you need and then getting it into a format you can use. Yeah, it's actually more than half. It's probably closer to, as I said, 70 or 80% of the work you do just to get to here. Now, the next step that you want to do is to model against that data. So I'm not telling you to create artificial intelligence yet or deploy predictive models. I'm saying that you need to infer, test, discard, and report back to your team. So back to your business team, to your own science team. And the reason you have to do this is to find out if you got it right. So this is the scientific method, as I said, kind of combined with business intelligence. So if you find out during the modeling phase that the data that you acquired in the acquisition phase and prepared so lovingly at expense doesn't answer the question that you were asking in step one, you have to stop. You know, you've literally, if you're using the scientific method, you've proven your hypothesis incorrect, and it's time to go back to the first step and start again. If you move forward, and I see it all the time, people have invested that 60, 70, 80% in time and money. They get to step 4, the model is weak, and they don't want to go back to the beginning, so they push forward, and then they end up with a terrible outcome, oftentimes no outcome at all, and they spend a great deal of money and time. So you need to be prepared to go through this step 1 through 4, and kind of, it's like you're doing it manually. You're finding out if you can even answer the question you were asking with the data you prepared that you acquired. Okay, but if you're lucky and if you get through it, then you're going to get to go on to the really fun stuff. When people talk about the implementation of algorithms in exponential organizations, they're almost always talking about step 5. They're talking about deploying machine learning. They're talking about deploying artificial intelligence to augment the business making process of an organization. This is where machine learning, deep learning happens. This is where models get created and deployed to services like Amazon Web Services in the cloud, and then they can bring in new data because now it's prepared and it's coming in clean to make new inference. And it's those inferences that then augment the business decision-making process. So you had to do a lot of work to get all the way to here, to get to a model, a predictive model that you could deploy into a production environment to help you run your business. Oftentimes, the thing that you create here at this level is going to be what you sell, because it's that predictive model itself that others will consume to do their work. That's what often happens with these types of data-driven models. And that's where it gets really important that you don't stop there, that you actually activate that data. I call this data activation, and it's this is where you take that predictive model and you wrap it in an API, you put a dashboard on it, you create a series of outputs that might be PowerPoints and keynotes, but you really go that extra mile to make that predictive model accessible across silos, both in and externally to your organization. And that's when you really start to hit on all cylinders with things like the ExO model. It's not the fact that you made a great model, congratulations. It's the fact that you activate that model in the world. And when you get really good at this, what I always tell people is pick an easy project first to go through all these steps so you can get some practice. then pick a little harder project and do it. So you want to be aiming for projects that might take 6 weeks, 12 weeks, and something like 9 months. So that way you're always working on projects and you're getting quick returns so you can show results to your teams. But at the same time, you are working on some harder goals over time, and those harder goals probably will aggregate all the capabilities that you create with those smaller projects, the lower hanging fruit. When you get really, really good at this entire 6-step process, it becomes more like a 6-lane highway, right, to data literacy and mastery. And you start involving all of the people in the organization throughout all stages of the project. These are 7 archetypes of the type of people in your organization that I typically see involved in these data science projects to activate data in their organization, to implement algorithms as predictive models that augment business decision making. So I will kind of end on that today for time reasons, and say that I'll come and take a look at the I'm going to come and take a look at the questions now, and we'll go from there. Let me get myself back in here, and I hope that gives us a nice foundation for some conversation. So John Stroud has asked some questions. Let me go take a look at that real quick. Thank you, John. Okay. So I'll read John's question. How do your clients decide whether to use tools from other people or to build their own? Let's start with that one. So there's something called not invented here syndrome. This is a particularly nasty form of a very expensive form of I guess a form of bias almost that people have. You should always build it if you can, John. You don't want to reinvent the wheel. There's not a lot of benefit to it. In fact, it will slow you down massively. You could spend a year just creating a tool that can create a predictive model. You could have gone out and got Databricks or used Amazon's machine learning tools in the cloud. You always need to start with the assumption that the tools you need already exist. Building something like Flow GL from scratch would take you years. I mean, those gentlemen have spent years creating those tools. So the decision needs to be whether or not it's part of your core business. So if you have a business that does data visualizations like Flow GL, then by all means, write it from scratch and sell it. But if you don't do that for a living, if your business is something else that could just leverage a tool like that, then you need to go and buy the tool. There's almost no cost that you pay for a tool off the shelf or with slight modifications that'll be more than the total operations cost of building it from scratch. It's almost always a mistake to build it from scratch. Not always, but almost always. Second question was, what are the criteria they have in mind? Well, I think I blended in some of that. It's, you need to look at you need to look at what provides you a competitive advantage. And this is actually part of the ExO type of idea is, you don't outsource the most central or core things to your business. You keep those in the core, you pretty much outsource everything else. So does it provide you a deep competitive advantage to do it yourself, right? To invent it here on premise? I think that's the number one thing. Now, you may find that you can't afford, sometimes tools are too expensive and you can't afford them. That could be a criteria where you might go ahead and build a simpler version of an outsourced tool to get you from point A to point B, make a little money, and then be able to afford the more expensive thing that you couldn't quite get at the beginning. It just depends on what stage your organization is at. Let's see. What are the points where clients typically fail when attempting to use algorithms that you can help them get over so they succeed? Well, I made the data activation framework to try to help people from failing, because what I saw people doing every single time was trying to jump to step 5. And the worst thing that I would see happen is they would jump to step 5 and 100% outsource the creation of their algorithms to some other team. Maybe they would even get a modicum of success, get those algorithms deployed, but then that becomes almost like a tax on your gross margins over time, and you can't necessarily afford to maintain those external teams for a really long time. So the big mistake I made is they don't build any core capability inside their own organization for data science. You should treat those external teams as professors, as teachers, to help your core team. So the core team is strong enough in the data science that it does and needs and wields, that should you lose an arm, like a division that you've outsourced something to, that the operations can continue, and that your own team is constantly upgrading their skills, capabilities, knowledge, wisdom, decision-making prowess, and ability to go through those 6 steps of data activation. If you don't do that, then really someone else owns your business. And I think you've got to really watch out for that. And this is, I've mentioned this very explicitly because it's rampant in this space, because very, very few organizations that I encounter actually have real data science capabilities inside their organization. They almost all have a lot of potential data scientists, because data science is very amenable to functional programming. And funny enough, Microsoft Excel is programmed in a very functional method. So you look for your Excel jockeys. Those might be your future data scientists in your organization. If you paired them with a data science expert from outside, using the staff on demand to process techniques, then, and that person was willing to teach, then you can really make a good balance between your core capabilities and external capabilities, so that it's a leverage, so that those external capabilities become leveraged assets, not liabilities. Really important. Gerardo, great presentation. Oh, thank you, Gerardo. Appreciate that. Been given this one for a while with my faculty role at Singularity University over the last 8 years or so. I've brought this model to probably thousands of people. Someday I'll finish the book. I don't know when. I've started to wonder if I'll ever finish that book. I literally do have a book called Data Activation and a publisher, but really having some trouble getting that book done. But yeah, this model is really powerful. And I'd say now, Stephen, we're at 50 after. I probably went over a little bit there for you. Sorry about that. But if you want to open the microphones, anyone wants to ask any questions, come on camera. Very happy to entertain that.
Yep, everybody should. If anybody wants to ask in live, you should be able to unmute yourself for sure. I know we have another question here, although it was sent in private, probably by mistake. But for a traditional business that wants to become EXO enabled, so how do they become more tech enabled in that sense? If they want to leverage algorithms, what are some of the initial data they should be looking at, for example?
Oh, that's a great question. So this is so much easier than people think, okay? What do you do? Start there, right? So what does your business do? Now, every single moment of every single day, you, all your employees, your customers, your vendors are doing something that's part of doing what you do. Every single moment of that creates data. The question is, where is it going? And in most cases, it's becoming what we call data exhaust or digital exhaust, whatever term you like. And so what you have to do is imagine like it's a wiretap. You need to tap into those data streams and start to observe what data your organization is generating. Every organization generates data. Most of them do nothing with it ever. Okay, so now that is where you'll start to find your first insight. As you collect that data and pair it with real business questions that you've never been able to answer before, and then go through those steps of data activation, you'll find that you create a data store or a series of data stores. I'm not a big fan of the centralized data warehouse or data lake. Now, they do have their place in the world, and sometimes they're useful, but I often find that data needs to stay where it's generated and then be tapped into with APIs over longer periods of time to create non-siloed versions of data science operations. But that might be a 201 version of this talk. But the reality is that you need to look where you do your work, the interfaces with your customers, the interfaces with your employees, the interfaces with your vendors. That is where you're going to find the data. And you'll find oftentimes too that even your vendors and customers have not laid claim yet to the data that's being generated. So think of it almost like a land grab, and this might create some competitive advantage for you as well. Let's see. Yeah, I really want to publish the book. You have no idea how much pain I've been through on that side, Gerardo. Thanks for the comment. How do you see the possibilities quantum computing could bring into this area? Okay, so quantum computing is incredibly fascinating because it lays open the possibility to solve certain types of algorithms that heretofore were completely not solvable in any human scale time frame. And we're beginning to see this actually happen in the world today. So what quantum computing is going to do is going to bring massive parallelization of the algorithm solving workflows that are available for a class of problems that some people know, the traveling businessman, traveling salesman type problem. This is where as you increase the number of nodes in a system, the amount of calculations required to calculate a path, the most optimal path through that data, which is a classic machine learning problem, increases not just exponentially, but even quadratically. And so in a case like that, where a classical computer, a binary, zeros and ones, could take thousands of years to find the optimal path, a quantum algorithm, a quantum computer with a quantum algorithm might solve that in a microsecond or a nanosecond for that matter. And so that changes everything. So imagine that applied to supply chain optimization. Well, guess what? The world's going to get a lot more efficient when we have quantum computers doing supply chain optimization. We're not there yet. We're still in the early stages, but that's one example, Gerardo. Will quantum computers help train faster models? Yeah, they will, because one of the things that you do in machine learning is optimization, right? You look for the optimized output and try to avoid overfitting or local minima or maxima. And quantum computers are going to allow us to explore larger problem spaces faster and find those optimal outcomes faster, as I was saying. Do I see that? How do I see this future? That's a fairly broad question, but it's not like quantum computers are going to take over, right? They're going to augment what we already do. I don't think we're anywhere near, sort of a commander data, positronic brain, quantum computer driven thing. I mean, we're so far from that. But I do think we're getting closer and closer every day to having optical computing, quantum computing, augmenting classical computing, and all of that augmenting people. So I'm really a fan of kind of the Kai-Fu Lee style of blended human AI future architecture of problem solving. I think that is I simply think that's what's going to happen. I don't see any other logical outcome. I'm not a fan of the Terminator scenarios. It's not that bad things can't happen when you let artificial intelligence run loose. It's just that, that I don't see that makes any sense. So I'm not really, I enjoy the dystopian films as much as anyone, but I think that's just not really the thing. Let's see, Eric, many thanks. Oh, thank you. Thank you very much, Eric. That model has been successfully deployed many, many times. So
awesome. And I know if there's one last question, or we're about to wrap up. Any last question or anything you want to kind of wrap up on, or for the audience?
Well, he one more from John here. Where do people buy data? That is a funny question. That's great. So remember, like I said, explore interfaces to find data sets that might help you solve business problems. And I mean it very much the way exponential organizations define interfaces. Okay, look at that definition and then think of your business in terms of interfaces. Human interfaces, machine interfaces, combined hybrid interfaces. Look at those areas, because that's where the data is flowing back and forth over the interface. And you will find that you may own some of that data. You will find that you do not own some of that data. Buying the same data that everybody else has isn't going to give you much of a boost, is it? So by examining interfaces between, as I said, your company, yourself, your vendors, your customers, that's where you're going to find the unique data. Then go to that vendor, go to that customer, go to that person and say, hey, I'd like to do a deal with you. And don't even think of it as buying. I think in the future, the best deals around the leveraging of the transformative power of data at scale are going to come from partnering. Deal them in. right? Make them a partner, make them staff on demand. They're generating data you need to solve problems that will give your business higher gross margins. Don't be greedy. Do a good deal with them and lock it up for a long time. So that'll be a good way to do it.
Awesome, awesome. Thank you so much, Kent. And today all of you have kind of dived a little deeper than you may have before in terms of algorithms. And again, all these EXO meetups, it's really meant as a way for you all to kind of get immersed in the process in some way, shape, or form, helping you kind of have frameworks through some guidance with some of the speakers that we have. And ideally, it's really to spark ideas, opportunities for you to grow, to apply to your business, or just connect in the process. So we're super excited that you've joined us today. Again, we have many more coming up: leveraged assets in May, engagement in June, and staff on demand and interfaces in July. And of course, we have EXO clinics where if you have questions, you want some one-to-one coaching or guidance around some of that, those clinics are open to all folks in the DC area, even beyond. It's a global world now. So feel free. Again, if you want more resources about OpenExO, openexo.com. If you need to go to see other meetups that are happening closer to your area, then you can go to the openexo.com/events list. And if you want stuff for entrepreneurs, or the toolkit, as you call it, that's a plug for Techstars on my end. But super excited. Thank you so much. Thank you, Kent, for giving us your time today. And thank you all for joining in, learning, and we'll provide the recording tomorrow, the latest.
Thank you, Stephen. Amazing. Find us in the OpenExO community if you have any additional questions.